So let's get started. Good afternoon, everyone. I hope y'all are having a wonderful day. I'm super excited to be here, even though I'm massively jet-lagged. Anyway, my name is Vibhanshu, and I'm a computer science student at the University of Waterloo. As you can see, the title of this talk is Functional Programming on the Web Using Elm. But essentially, it's a 20-minute long argument on why you should ditch JavaScript. And best part, there aren't any brackets in the syntax, at least not as much as Lisp, so good for you. Anyway, so this talk is essentially about writing front-end code in a functional paradigm using a language called Elm. I will not go into too much detail about functional programming per se, but this is what you can expect the talk to cover. I will introduce Elm. I will talk about how it compares to JavaScript and its benefits. I will talk about the Elm architecture. I will talk about a few features of Elm. I will talk about the package system. And I will talk about some caveats before you use Elm at your workplace or in your projects. So functional programming is based on, let's say, these two core ideas, that every function is understood solely in terms of its input and output. The only thing that a function should care about is what it's taking in and the value that it spits out. And the other major concept is immutability, in which essentially there is no such thing as a variable. Everything is a constant. Variable's value never changes. This helps eliminate a whole class of bugs. So Elm, what is it? It's a strongly typed functional language that compiles down to JavaScript. You can write web apps with it. And essentially, I adore it. I think it's delightful to use. Elm is, unlike Haskell, Elm actually focuses on simplicity. It's not overloaded with complex features. And with every new release, the language is somehow made simpler to use. Elm is statically typed, and it also supports type inference. All the functions are pure and are referentially transparent. Referentially transparent essentially just means that you could replace a function call by the value that it produces, and the code's behavior would not change at all, because the function does not have any side effects. That's a great thing. So those of you that have worked with JavaScript probably run into these errors on the screen almost on a daily basis. This is the bane of JavaScript, errors during runtime. Undefined is not an object, or this property does not exist on null. And I don't know about you, but let's say you've built a user application and your user is clicking on something and bam, they're greeted with a massive crash in their face. Now, I don't know about you, but I like when my apps are reliable. I like when the software I write does not crash. So enter Elm. And this is the biggest selling point of Elm, that there are no runtime exceptions. Essentially, it's saying that your program will never crash. I think that's a beautiful idea. And yeah, personally, as someone who likes reliable software, that's great. But how does it manage that? Well, first of all, Elm does not have any concept of null, undefined, and exceptions. Those just don't exist. And since it is statically typed, types are our friends. You cannot, in Elm, set a string's value to be null and be on your merry way. A string cannot be null in Elm. And you're going to hear me talk a lot about types in this talk, and there's good reasons for it, as you'll see. So what comes built in Elm? So what you see on these left is the features, and in brackets, you see the libraries that you need to install in JavaScript to get those functionalities that come built in Elm. So pure functions, immutable data structures, currying, type checking, et cetera, et cetera. I had a friend who said that you could just install all these libraries and write functional code and good code in Elm. And that's why he liked JavaScript, because you could always then do things imperatively like you do in traditional JavaScript. Needless to say, we're not friends anymore. All this comes for free in Elm. You don't need 100 different things to write good code in Elm. Elm actually takes freedom away from the developer in this regard. There is only one way of doing things in Elm, and that's the correct way. You can't get around it. Every app in Elm is based on the Elm architecture. No matter what it does, no matter how complex it is, every Elm app breaks down into three main components. That's the update function, there is the model, and there is the view function. So let's talk about the model first. The model is the place where all your application's data lives. It's an immutable data structure, and all the data that can be associated with your application always lives in the model. Then you have the update function. The update function defines how the model is updated. And then you have the view function, which defines how the model should be rendered on the screen. In the background, all this is handled by the Elm runtime, which communicates with the browser. It does things like register click events and pass them to Elm code. It tells the browser how to render things. So let's just work through a simple example. Let's say a user clicks on something on the website. That essentially fires off a message. Elm runtime passes off a message to the update function, and then the update function, in which you have defined how to handle that message, updates the model to a new value. And that, since model is immutable, a new value is generated every time. So that new model is then passed on to the view function, which then generates something that's called a virtual DOM. It's different from the actual DOM. It creates its virtual DOM, and then it compares to the actual DOM that's in the browser. It compares those two things, and then figures out the minimum number of changes you need to apply in order for the changes to reflect. And this is exactly how React is so performant. It minimizes DOM updates. And Elm has the same concept, so it essentially has the same performance as React. Some of you might also notice that this architecture is very similar to the Redux architecture that you have for building front-end applications. Fun fact is that the Redux architecture was inspired by Elm. And another massive difference between React, Redux, and Elm apps is that in Redux apps, the application data can live in multiple places. You can have data that lives in components. You can have data that lives in the stores. You can have, and all these data is mutable, so they can change at any time. And this leads to what I call multiple sources of truth, which cannot happen in Elm. In Elm, all the data is stored in your model, and whenever that is updated, view is triggered automatically and appropriate commands are fired. And just like React, you can embed HTML in your view function so you can define exactly how you want your DOM to look like. And do keep in mind that the update and view functions are entirely decoupled from each other, which is great design. So let's talk about features of Elm. And the first feature I'm going to talk about is the type system. Types are a core idea in Elm. The language forces the developer to design around the types. And since it's statically typed, the compiler ensures all the data that flows in your program is of the correct type. I find this to be a great advantage because the errors, when compared to a dynamically typed language like Python or JavaScript, are caught at compile time instead of runtime. And that means that fewer crashes when a user is actually using your application. And some people say that static typing is somewhat restrictive, and I agree. However, I also think that it's a great thing. In my experience, the stricter a language, the better. And types in Elm really force you to think about the design of your program up ahead, and that leads to well-designed programs. Just to focus on something in this talk, I'm going to talk about custom types, which are also known as union types, and they are the most important feature in Elm. If you learn to use custom types correctly, you've figured out and you've mastered Elm. We will look at a few examples of those. So let's say we're building a chat room, and we want to be able to model the users in that application. For this, you will define a type, and you will say the type user is a union of 3 different types. You can say that it's a regular user, and that carries with it some associated data. So string, which could be its name, integer, the registration number of that user, and the location, that's their current location. Then you can have another type, which is a visitor, which just has a name associated with it in a string. And then you have the anonymous user, which has no associated data with it. And custom types become extremely powerful when you model situations in your types as close to reality as possible. Different variants of a type can essentially be described as a union, and they may or may not carry associated data with them. Another type that we will need is the message type. So the messages is what the Elm runtime passes on to the update function, and that will define how you update the model. So for our chat room, we will essentially want these types of messages. We want to be able to handle the case when the user presses enter. So that's the pressed enter message. We want to be able to handle the case when the user has changed the message they're typing. So we'll call that a changed draft message that also carries with it a string, which is essentially just the new message that the user has typed. Then there's a received message type, which is what's triggered when you receive a new message, and that carries with it some associated data, like the user that it's coming from and the message that it is carrying. And the last type of message that we will want is clicked exit, that the user has clicked the exit button. Now, as you can see, these are completely different types. Like, these are just completely different types of events. But with custom types, you can actually have them defined in one type called the message. And we will see how this is useful and how people actually use it. Another example and another type is, let's say you have a profile page in your application, which displays the profile data associated with the user. And you want the type profile to then represent these three scenarios. The first scenario you want to display or handle is failure, is when you fail to receive data from the backend. So you will model it in failure. The other type would be loading, and the other would be success. And success carries with it associated data. Now, why it's useful is when you will write the view function for the profile page, you will have to handle each type accordingly. Like, you will have a case statement for the failure, you will have a case statement for loading, and the case statement for success, which means that your application can never crash because you've explicitly handled every possible scenario. And that is how, just an example of how we will utilize custom types with pattern matching. So just for the syntax, by the way, no parentheses, you have the update. The update's type signature is that it takes in a message, it takes in a model, and it returns a new model and some command that you may want to perform, such as playing a sound or something. Regardless, update takes in the message and the old model, and then we will pattern match on the message type. Since the message could be of type pressed enter, and then we'll define what to do there, then changed draft, which carries with it the new text. You will say that, OK, take the old model and set the draft field of it to new text, and don't execute any command. Similarly, you will handle the received message case, and similarly, you will handle the clicked exit. The compiler will ensure that you've pattern matched on every single one of those possibilities, which is great because it makes you handle every single case in your code. Another example, and a simpler example of pattern matching is when given a profile type, you want to be able to retrieve the name of the user. So you'll say get profile name. It takes in a profile, returns a string, and then you will again pattern match on profile. In case of failure, you will set it to whatever you want to set it to, similarly for loading. And in case of success, you just get the name out. Again, you're handling the case of being able to display the user's name regardless of whether you were able to retrieve it or not. Functional programming and static typing can be quite painful without a good compiler. And that's where the Elm compiler comes in. In my experience, it's the gold standard for compilers. Like, the error messages are always descriptive, and they're always super useful. Just as an example, look at this error message. I had like tears of joy when I first saw this. So not only does it tell you what is wrong, it tells you where it's wrong, it tells you why it's wrong, and it also tells you where you can read more about that error. And this is great, because this concept is somewhat complicated, and when I first saw it, it was hard to grasp. And without this error message, it would have been a lot harder to understand what was going on. But this is simply beautiful. And another example of, let's say, a very simple case where you have a list of integers and you want to extract the first element out and add 14 to it, for example. In JavaScript, you would have the array, you would index with 0 and just add 14 with it and be done with it. That is extremely error prone. And just as a contrast to how Elm does things. So Head is a function that takes in a list of elements of type A, and then it returns what's called a maybe A. A maybe A is a union type of just A, which is the value, or nothing. Nothing is the edge case when the array is actually empty, so there is no such thing as the first element. So now, in your code, when you write, OK, you have the list of elements, you extract the first element using list head and call it on elements, and then you want to add head. That's the function definition, and you would pattern match on the first element. Now it could be a case of just A, in which case it's a value into it, or it could be nothing, and you would just return 14. Now, compiler won't let you compile this code unless you've explicitly handled the nothing case. And that is why it won't crash even in the edge case scenario of the array being empty. In JavaScript, you would again just get undefined plus 14 is whatever. The compiler is really the biggest friend that you can find here. Another great thing about Elm is the package system. So let's say you're working on an Elm project and you have a dependency, and the author of that dependency decides to upgrade their library, and they accidentally introduce a breaking change. They break what has been working previously, and they decide to publish it to the package manager without bumping up the major version number. Elm won't let you do that. Because of the type system, it will figure out that you have actually made a breaking change. This is a completely new feature that's incompatible with what's out there. So it will reject your changes until you bump up the major version number. This is in massive contrast to NPM, which is like the Wild West. And a very famous example was the _JS library. They just bumped up the minor version number, and they introduced a lot of breaking changes. So people just upgraded their projects, and everything started crashing everywhere. This just won't happen in Elm. And the idea is reliability. You want your code to be reliable. You want there to be no unexpected breaking changes. And just some caveats before you use Elm. Elm is a relatively new language. I think it's only about 4 years old. It's a new kid on the block. Not many people use it. Therefore, there are fewer questions on Stack Overflow, our favorite website, and which can make it quite hard to fix the errors that you run into. There's also, like, the ecosystem around Elm is immature. And by that, I mean that there is a lack of good libraries. There just aren't enough libraries written natively in Elm. For example, you don't have an audio library yet in Elm. So despite this, and another thing is the personal pain point is JSON parsing is a massive pain in the ass, and lack of production-ready tools because it's such a new language. But despite all that, like, I find Elm quite delightful to use. Before Elm, like, I was turned off on the whole front-end thing. I did an internship writing React and JavaScript code, and I figured that that is the end of it. But then I stumbled upon Elm, and I'm actually enjoying writing front-end applications again. It's a lot of fun. It's so simple, yet so powerful. And yeah, essentially, from this talk, I hope that all of you try out Elm. I suggest starting out by making a game. That's how I started out, and I found it very rewarding. Yeah, and that's all, folks. Go and play with Elm. Shout out to the organizers of StarCon for organizing this. It's been fun, and thank you for listening.